Okay, so hello. Today we are gonna walk through the next paper, and this is quite related to the discussion that had previously. And this paper is about the future of digital health with federated learning, and it's a newer paper that is being done by 2020. So we're gonna discuss it today and see what are the highlights from this paper. So first of all, this been done by this been published in Digital Medicine and by Nicola Rieke, as you can see, and Johnny Hancock's and some other great researcher. A lot of researcher actually in this paper. And let's look at it and see what are the highlights of this. So again, this walk through the same problem that we have in the conventional and traditional uh, models, that we share all the data with the central servers, and again how we trust that server. And beside this, the cost of sharing is so high, and also that's kind of like an IP of the a lot of companies, so they're not going to share that anyway sometimes. So we have different ways to do that. One of them is federated learning aggregation server, which means that each model train locally, and finally they send it to a server to do all the aggregation, and finally the aggregated data is shared. Aggregated model is shared with the all the hospitals. Or the other one is peer to peer, which means that each device, there is no server here. Each device or each hospital is doing the training locally. And finally, at the end, they share the model, their weights with each other, and then they update accordingly. So this is probably less popular anyway, because it might be nice in the environment that probably we have less trust to a central server, but also it's a lot of sharing, because like each node not only share with one central server here, but you see this specific node or hospital had to share here with three other hospital, instead of just sharing with one central hospital. That is going to be much easier. So we talked about the IID assumptions that we don't have actually in that IID assumption here, which means that different hospitals have different amount of data, and even they have different type of devices. Like, I mean, if are you talking about CT scan or MRI, not every hospital is using the same type of MRI or CT scan, so you have to keep that in mind. And also the data that's been labeling, some hospital might do a good job, so some hospital might not do as that good. So that's something to take into account. The other concern that we might have is about the information leakage. I have mentioned this previously a couple of times, and that's about like that you can actually, even if you share only the weights of the model with the server, still the server might be able to learn some stuff about the original data that you used for training. So they kind of like can inverse the model, which means that they do run the deep gradient reconstruction. So they reverse engineer the parameter adjustment and then reconstruct the recognizable diagnostic slices. And even worse than that is that a malicious node can conduct something that is called gradient ascent memorization attack. So I just write it down in case you are searching about that. So this is called gradient ascent memorization attack. And that is when a rogue or malicious node or hospital can intentionally craft some malicious local updates that kind of force the global server to memorize the private features of other hospital patients. So is that like, do you trust the other hospital to be sharing good models or malicious updates? So that's something to have in mind. But usually we can solve this problem with something that is called differential privacy. That we'll talk more about that later. which is a very nice way to tackle the privacy issue. What it does actually is very simple. We add like a noise, like a Gaussian noise to each node. Like let's say this is our first model, or this is hospital one. So hospital one do a local training, training, and then we add a noise to that, like a Gaussian noise, a bit of error, and then we send this to the server. So in that case, is like each node or each hospital is using a different amount of error. So that makes it more difficult to figure out what was the original uh, image that hospital one used for training. What else to say about this that might be important? You remember that in the first paper we talked about the Google's framework, and we talk about it, how Google is considering like millions of mobile devices that have a slow speed for uploading data to the central server. Just I want you to have in mind that when we talk about hospital, that is not the case anymore, because hospital usually have good internet. So it's okay for them to share like more complex model or more amount of data. So they have a better network connection as well. And also they can have GPU clusters since they're not using just a mobile phone. So it's okay for them to run their local network with higher power. And the other thing that you might want to consider is that we want our models to be explainable, which means that if a model output is incorrect, so we cannot really pull up a specific scan and just see what is wrong with the pixels. Instead, since we cannot do this, in modern federated learning, we have to have an intranode viewing, which means that we should be able to look at feature attribution maps to understand like what are the unexpected results. And the other thing that this paper discusses about the financial consideration, like if a hospital is sharing more data or a pharmaceutical institution is sharing more data, probably they want more share. So in that case, how we decide like who is doing the majority of the shares and who should get paid more often. So there are techniques that we can use for that uh, to make sure that we understand exactly which hospital did the majority of the contribution. And one of them is the integration of data Shapley values. So it's called data Shapley values, which is like a game theory metric that measures the exact marginal contribution of each of these institutions. What else to talk about? Let me see if there's any other point in this paper that we see together. Just quickly, I clean up here. Yeah, I don't want to repeat myself. Of course, a lot of things repeated really in this paper. But this is mainly a review, of course. They mainly talk about some consideration they have, and also like the centralized repository that they consider K clients, that they send the weight from the server to the client, and then we start to update the weights by each client, and then we return the weight. Because this is actually an aggregation stage, because like each model, after they update the model, they send their weight to the central hub or to aggregator server to do an federated averaging of that. I think we have talked about everything. It's not a very complicated paper. So yeah, we'll meet you in the next paper to talk a bit more about the technical issues. We're gonna move smoothly towards uh, the privacy and security issues. So that's my ultimate goal. But I gradually talk about first the foundation of federated learning, and then we talk more about the security aspects. Thanks for watching.